Hello, hello. We are continuing on with the third section of week 4 notes, which is about preparing. So this would have been lab stuff, but preparing a standard solution from solid. Wow. So what this would involve, guys, is you're trying to create a solution that you know the concentration of, that's why it's standard, and you'd be taking literally solid chunks of something and dissolving it. Now, you've made solutions many times, just not maybe as carefully as this would be. Let's go back to iced tea. If you take scoops of iced tea mix and put it in water, hey, you've just made a solution from a solid, right? Same. Now, if we were in class, this would have been one of the labs this week where you would have had to make a solution from a specific given mass of a substance. And then the next step, which we'll do in podcast 4, is how you would then take that solution and dilute it to make another standard solution. Now, our first focus, like I said today, is taking a mass of pure solute, which will be a solid, and then dissolving it in a specific volume of the solvent. Here we go. Step by step. Yes, you should know these individual steps. The beginning is a calculation. And guys, there is a YouTube video that goes with this that's written into the notes. Make sure you watch it, please. It makes such a difference. It's not my video, but for you to actually visually see how someone does it, see the equipment, because ultimately you are responsible for knowing how to make solutions in chemistry. You'll get more practice in Chem 30, but it's important for you to see the glassware, see the process, look at the proper lab technique. Okay. Now, going back to this, when we're calculating the mass of, as I said, the solute, I'm talking about calculating the mass of solid that's required. And you doing this is going to be based upon what the concentration is. So if you know that you're trying to make a certain volume of solution and you want it to be a specific concentration, well, as long as you have those two things, you can get the number of moles. The number of moles, of course, is super useful, because we can rearrange the formula for moles to get the mass. Take the number of moles times the molar mass of the solid, and wonderfully, you've now just gotten the ability to calculate the mass required. Once you have that mass, we're going to use a nice accurate balance and actually get it, right? So if you were told, or I shouldn't say told, but calculated out, say you needed 1.32 grams of solute, measure it with the electric balance, and we're good to go. All right, that's steps 1 and 2. Let's move on to the third step. In this third step, we're going to take that solid that you carefully measured out and just put in a little bit of water. And the point of that is just to dissolve it. So you would do this in a little beaker, put your solid that you carefully measured out in there, and add just a little bit of distilled water. Now, distilled water, guys, means that it doesn't have any dissolved minerals or any other added compounds. For example, tap water is far from dissolved. There's lots of additives, lots of things dissolved, so it's just not pure, and potentially it will react with the things we're trying to make a solution out of. So distilled water, perfectly pure water. All right, so we dissolved it in there just a tiny bit, and now we're moving on into a new piece of equipment. These are beautiful pieces of lab equipment, volumetric flasks. And volumetric flasks are actually hand-blown glass, and they are really accurate in terms of volumes. Always clean these things out before you use them with distilled water. Ultimately, they come in a variety of different volumes. There's quite a few that are 50 mils or 100 mils or 200 mils, 500, 1 liter. You get the idea. So you'd pick the one that you require for what you're making. And like I said, lovely and accurate. We rinse it out, and then the solution that you made in number 3, right? This solution is going to be transferred into the volumetric flask. Now, interestingly enough, you always want to make sure before you transfer it in that you fill it with a little bit of distilled water first. And the reason for that is a lot of times when we make solutions, a lot of energy is actually released. It's called an enthalpy of solution. And it can be so much energy that you will break the glassware. I've had students years ago not listen to this and do this and actually explode the glassware because of so much energy released. Now, think about this. This happened when they were making acids. Solutions. And if suddenly you have broken glass that is exploded out, that is covered in strong acid, that's kind of an awful recipe. So half filling with distilled water is important. Okay, so we transfer the solution into this, and then we fill this volumetric flask up to what's called the calibration line. And this calibration line is right here, guys. I'm highlighting it there with yellow. And that's just a careful line that we can use to accurately measure volume. Do keep in mind, if this is the calibration line, we always measure to what's called the bottom of the meniscus. So on the sides of the glassware, the water naturally is cohesive to the edges. So an accurate measurement has to be to the bottom of it. Okay? And last but not least, stopper it. That's what this is at the top there. And mix it to make sure that all of the solute is evenly distributed through all of the solvent. Now, in terms of how do you actually do these types of calculations, they're very similar to what you've done before. You need to know the concentration goal. You need to know what you're making a solution of, lithium nitrate in this case, and you need to know how much solution you're trying to make, right? Your very, very first step then is, of course, you have to do that calculation. How could you possibly make a solution if you don't know what mass you're actually going to put onto that electronic balance? We have to know what's going to go in here to make the solution. You're also going to need that lovely 100 milliliter volumetric flask so that we have the right thing to put the solution into to accurately make the amount we want. All right, calculation-wise, look at your givens first. So concentration is 0.180 moles per liter, and the volume has been given to you in milliliters, but in this scenario, we have to convert it to liters because that's what the concentration is in. So I divide it by 1,000, then I've got 0.100 liters. What's the whole point of this? Well, it's actually really useful. If I've got C and I've got V, I have enough information to get the number of moles. That's huge. Once you have number of moles, I can figure out the mass. Okay, so let's do that calculation. C is equal to 0.180 moles per liter times the volume of 0.100 liters. Multiply those two things together, you get 0.0180 moles. Now, all that gives us is N. We need the mass though. Given N that we just calculated of 0.0180 moles, and knowing the molar mass, ding, 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 of, get the correct formula, we're back to that again, guys, lithium light nitrate, both have a charge of +1 or -1, so our formula is LiNO3. So calculate the molar mass of that, you'll get 68.95 grams per mole. Now, formula-wise, rearrange the formula for moles. We get M, mass is equal to N, times the molar mass. So 0.0180 moles times the molar mass, 68.95 grams per mole. Number crunch those two together. Watch the sig digs. We're going to have 3 of them. 1.24 grams. In other words, this is the mass of lithium nitrate that we're going to have to measure out on that electronic balance. Now, guys, to answer this question, if you look at the notes that I posted on this, there's a lot more to go here. I'm not going to write it all down, but you can imagine. Next step, while you measure it. Third step, dissolve exactly 1.24 grams of that lithium nitrate into that small amount of distilled water. Make sure you have a clean 100 ml volumetric flask. It's been cleaned with distilled water. Now transfer this solution into it, but make sure there's already some distilled water in that flask before we put the solution in. Okay, fill it up with distilled water up to the calibration line, and stopper it and invert it. Dun, da, 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 a properly made standard solution from a solid. Question-wise, there's only one question related to this concept. Lucky you, it's number 10. You should complete it, but you need to write down step by step exactly how to make the solution. All right, guys, have a good day.